Howdy AP PreCal, it's Miss Kosh, and we're going to talk about polynomial division in this video. So when dividing polynomials, it's always possible to use long division, and then this one is synthetic division is most efficient when dividing by something linear, but it's not required for AP, so which kind of surprised me, but they forgot to consult me. So I'm going to do both just to kind of refresh your memory. I think you probably learned both in Algebra 2, but here we go. With this one, since this is linear here that we're dividing by, if we can use x equals 5 as with synthetic division. So as a reminder, I draw my lines slightly differently than I think everybody else in the world does, but whatever. But we do need, notice there is no x cubed term, so we have a 0 for the x cubed, 3 for x squared, -5 for x, and 2 for the constant. And I'm going to put 5 here on the outside. I bring this number down, I multiply, I add, I multiply, I add, I multiply, what is that, 140, I add, I multiply, I think this is 675 because what I remember is this is 677. And so we have done this division. Now what they're asking us, this I think is a review for you. Now when they say this, they want it in the form P of x is equal to Q of x times D of x plus R of x. What they're talking about is if I take my polynomial P, my original polynomial, and I divide it by the divisor, okay, then, well, okay, let's see. We'd have, I need scratch paper. Okay, if I took P of x and I divided it by my divisor, D of x, I would, if there is no remainder, then this would equal Q of x. Okay, so then I could multiply this back and we're kind of here. But not everything divides nicely. And so things where there's something where it doesn't divide nicely, we have to add on this R, the remainder right here. Okay, so we're going to practice writing it in that notation. I've seen this in my IB world, but I also have seen it now in how College Board asks for this in AP. So they had a slight variation on this. This is a little closer to what IB says, but it's the same idea. They had like f of x equals instead of p of x. But the polynomial, this is the quotient and the divisor, and the remainder is kind of where those letters come from. Okay, so what we had here was that we have p of x was x to the 4th plus 3x squared minus 5x plus 2 is equal to, well, what did we get? Our final answer, this would be the remainder. Here's the constant, the linear component, the quadratic, the cubic. So this is 1x cubed plus 5x squared plus 28x plus 135. I'm going to encroach on that space over there. Maybe I'll just use another piece of paper. Plus, what was my remainder? Oh, no, this piece right here was multiplied by the divisor right here, x minus 5, plus we had a remainder of 677. And that's what we need to do. Okay, I will write too big to be able to use that space for the next one, so let me jump over here. They had said 2x cubed plus 13x squared plus 19x plus 6, oh, you can't see what I'm doing, there we go, is being divided by x squared plus 5x plus 2. Okay, what I like to do is I like to stay very consistent. I like to have a column. Anytime, my column will all be like terms the whole time. So anytime I need to write something down anywhere, if it's going to be an x cubed, it's going to be in this column. I even follow that rule on the top. You don't have to, but I do. Okay, so what I'm going to start with is 2x cubed divided by x squared gave me 2x. Notice I just said 2x, so I wrote it in this column. So multiply back. 2x cubed, multiply here, that's a positive 10x squared. That becomes a positive 4x. And now I subtract, subtract, subtract. When I was doing my answer keys, I changed color, but I don't feel like finding a different pen. So 3x squared plus 15x plus 6, I bring down whatever's here. And then I can say 3x squared divided by x squared is a positive 3. Okay, let's multiply that back, 3x squared plus 15x plus 6. I was multiplying 3 times this. And, oh, notice they match exactly, so when I subtract, we're left with 0. So when they want me to write it in the form P of x is equal to Q of x times d of x plus r of x. Notice we don't have a remainder. So really and truly, we don't have to write anything there, but I'm going to follow this pattern, and I did follow the pattern on your answer keys and stuff. Okay, so this would be 2x cubed plus 13x squared plus 19x plus 6 is equal to, well, what did I get? It was this, 2x plus 3. What did I divide by? I divided by that. Oh, you couldn't see all that. I'm so sorry. X squared plus 5x plus 2 plus, what was my remainder? It was nothing. And there we go. Okay, so far so good. Let's see if we can get these. Okay, so it's a similar idea. I just asked the question in a slightly different way. They're giving you this equation, this p of x equals q of x times d of x plus r of x, but now they're telling me the p and the d. So what we want to do is we want to take the p, the polynomial, and divide it by d so that we can then find q and see if there's a remainder. Once again, this is linear. I know that synthetic division is not a component to AP PreCal, but they're not going to tell me I'm wrong if I do it and I do it correctly. I think. We'll find out. Okay, so 2 times negative 2 is negative 4. That's 3 times negative 2 is negative 6. That's 4. I'm going fast. I make mistakes. Not too often, but I do, so my apologies. Okay, so what does this mean? This means that this polynomial, 2x cubed plus 7x squared plus 10x plus 15, is equal to this, 2x squared plus 3x plus 4. So this polynomial was equal to this part right here comes out as the x squared, the x, and the constant, plus, oh, nope, I was just testing you, times x, that's a time, anyway, x plus 2, and now I have plus a remainder of 7. Okay, the next one, oh, I'm going to run out of space again. Well, let's see what I can do. Okay, notice I have an x to the fourth and x to the third, but no x squared, so I need to hold a spot for that. So 0x squared minus x plus 1. And I'm dividing by x squared minus x plus 1. X to the fourth divided by x squared gives me x squared. Let's multiply it back. X to the fourth minus x to the third plus x squared. Notice my whole column always, they're like terms. When I subtract, well, that changed that, subtract. This is gone. My goal is always to get the first thing to disappear. If I didn't, I did something wrong. Okay, so then this is 5x cubed minus x squared. Let's bring down the next one. Now 5x cubed divided by x squared is going to be a positive 5x. I did not save myself enough space. Here we go. 5x times that gives me a 5x cubed and a negative 5x squared and a positive 5x. We're going to subtract, subtract, subtract. That's gone. This becomes 4x squared minus 6x. Bring down the plus 1. Okay, 4x squared divided by x squared is a positive 4. And then I can multiply back. I have 4x squared. I have a minus 4x. I have a plus 4. Subtract, subtract, subtract. And that's gone. This becomes a negative 2x and a negative 3. Oh, there you go. Okay, and so here is the answer. Oh, well, way over here. Okay, here we go. So we're going to take our polynomial that we started with, x to the fourth plus 4x cubed, you can't see what I'm doing, minus x plus 1 is going to be equal to, well, what was our answer? Well, that's not entirely our answer, but it's this times this, what we divided by, plus our remainder. Our remainder was negative 2x minus 3. Okay, I kind of encroached on my space, but do you see what we're looking at here? If you would like to factor out the negative, because this first one is negative, don't let me stop you. You could write x squared plus 5x plus 4 times x squared minus x plus 1 minus, and then factor it out, so it's a 2x plus 3. I'm fine with that. I think that is the sum total of the division notes that I wanted to do. Yes, because now we're moving on to binomial expansion. So come back and find the next video.